Hey, I'm Tom Gocze. This week on Hot and Cold, we're down in the basement for a reason. We're making hot water a different kind of way, and you got to come back to see what it is. So we're down in the basement, as I say, because we've got a project that I've been looking forward to doing, and it's been a while in coming, but it's here now and it's working fine, and I want to show you all the great details. We've got a Nile Corporation heat pump water heater. This is the actual water heater right here. It's hanging on the wall, and what it's doing is it's making hot water in the basement. It's taking basement air, it's cooling it down, it dehumidifies it, and in the process of extracting heat, as it cools down the basement air, it makes domestic hot water, which would normally tie into your electric water heater tank. In our case, we have an 80-gallon stainless steel tank here, and it's making hot water and keeping the basement dry in the summertime. And it's got a couple of things. Again, it's engineered for tying into your electric water heater because it's an appliance that is more efficient than a standard electric resistance water heater. Here's the reason why. An electric resistance water heater excuse me, is what we might call 100% efficient, in that all of the electrical energy that goes into the resistor in the tank makes hot water. The dilemma is electric hot water is expensive because electricity is expensive. I can't even say it, it's so much money. And you know that because you pay electric bills here in Maine. What a heat pump water heater does is it sucks air through the unit. It goes in through here, and I can take the cover off. This coil here is full of refrigerant. It compresses the refrigerant and makes heat, and it exhausts, so it brings relatively warm air in here and exhausts air out over the side here, cooled down. In the process of cooling down the air, it compresses the heat that's in the air that it extracts and makes it into usable hot water. So it's a relatively simple concept. Refrigeration is not simple, and I don't claim to be an expert. I do know that it works. So what we're going to do is we're going to look at this whole installation today and get you up to speed on what it does, its pluses and minuses. The unit hangs in the basement. These kind of water heaters over the years have been made with and without tanks. Usually they sit on top of a tank. I like the separate unit because it gives me the luxury of keeping it off to the side. If anything ever failed on it, if it needed service, I could disconnect it, take it out to be serviced. If the tank ever fails, we've got this modular aspect to it. The two are segregated. So if there's a problem with the heat pump, it can go out for service. The tank fails, we can replace it. The heat pump stays in place. Our installation is a little bit different in that we've engineered it for a standalone tank. Normally this would tie in with your 40-gallon hot water heater tank. I've got an 80-gallon stainless steel tank here. I just happen to have, because I have stuff like this. And we are configuring it just slightly differently, but the whole basic concept is the same. Down at the bottom here, we've got cold water coming in, goes into the bottom of the tank. The cold water line is blue because all our plumbing is color-coded here in the basement. Hot water comes out the top of the tank and goes to our manifold system. The other tie-in we have is we have a line over here. This white line is the hot water that is coming, the cold water. Let me get this right now. This is the cold water drawing off the bottom of the tank. I get confused. And that goes to the heat pump. The heat pump has its own pump in it, circulator pump. Then hot water discharges in this line here into the top of the tank. And that part of it is fairly simple. There's a lot of different ways to tie this in. They have a hookup kit that allows you to interface with any kind of electric hot water heater. Obviously, you can plumb into any other kind of tank too. The controls are a little bit different. We have an aquastat down here The original aquastat that was on this tank, which had a knob here for adjustment, was defective, so I've bypassed it, and behind here I have an aquastat installed that is adjustable, so I can make hotter or colder water depending on what it is. We've got it just set where I want it to be, so that's perfect. And that sends a control switch into the unit, and we'll take a look at the unit in a minute here. This is the control line, goes up in the unit, turns the unit on and off based on how hot the tank is. Obviously, it's running right now. What you're hearing is the blower. There's a circulator pump and the compressor. We'll take the cover off in a minute. You'll hear the compressor running as well. Not much else. This normally would wire in. This would be the power lead for the unit. This would normally wire into your electric water heater. I've got it going to its own power line because I have no electric water heater. It just shut down here. It's just going through its shutdown cycle. So it's a fairly simple device. I have the cover. Normally, you never leave electrical boxes open. I have left the cover off of here because we have a clip-on ammeter which will measure the current that's going into the unit. And I check it every so often just to see where we are. Right now, where it's in a shutdown mode, it's not pulling any current to speak of. It's only pulling about 1/10 of an amp because just the blower is running. So, pretty simple device. One thing this does in addition to chilling, normally in an average size basement, this is a smaller basement, average size installation, this will chill the basement down a degree or two cooler than it would normally be. Which is not normally a big deal in a basement. We've got a bunch of things we want to fool around with this device come winter time, and we'll get into that more when we get into winter time. This will be sort of an ongoing project that we will look at in terms of operational cost, in terms of what we can do with it to make it be part of an energy management plan within the house. Right now, it's more of a management plan in the basement in the summer to keep the basement dry. And I mentioned keep the basement dry because this also functions as a dehumidifier. And down on the bottom of the unit here, there's a pipe, a tube that comes out. This is a drain tube. I've got it hooked into a piece of PEX tubing, and if I'm not in the light there, occasionally some water drips out of it. And we've got about 2.5 gallons of distilled water in this dirty bucket that has come out since about Wednesday. And when I need water for batteries or whatever, my wife's iron, I have some clean containers that I fill up, and we hope that it's humid out. But usually there's enough water. We probably generate at least a half gallon a day this time of year, this being August. And it'll be less in the winter time and more in the summertime, obviously. So we either need to empty the bucket every so often or run a drain line or a hose over to a drain line, which we could do. I've not done that here because I want the distilled water for my many nefarious uses. Anyway, we got to take a break here. When we come back, there's a cover that comes off of this, so we get to look inside at all the little bits and pieces, and we can see what kind of noise they make and what they do and all that good stuff. Stay with us. We'll be right back. Hey, we're back, and we're looking at the Nile Corporation heat pump water heater, which it's also known as an air-to-water an air-to-water heat pump. We're taking heat out of the air, heating up water. This unit will deliver 6,000 to 7,000 BTUs of energy per hour while it's running. A couple of things we got going on here. One is this is mounted resiliently in that we have rubber dew flickers here, little donuts, and the unit is floating because it does make some noise. It could sit right on the floor. I don't want to have it right on the floor. I wanted it up near the ceiling where it's going to get the warmest air. A heat pump likes to have as warm air as possible to make hot water. So up closer to the ceiling is warmer. If we wanted to try to extract warm air from upstairs, maybe if the wood stove was running or something, we could vent upstairs. We could tie a vent onto here, take this off, and put a piece of ductwork here and draw air from upstairs. And for that matter, we could discharge air upstairs through here as well. This uses Armaflex pipe insulation, which you can see I have not done a good job of sealing. This should be either glued or taped together. I will do that at some point. I'm just happy to get the thing running. Also, there should be, I should point out, insulation on the top of the unit here, and on the hot water pipe especially. That's not been done yet because I've done it. You should do what I say, not what I do. Anyway, if we pop the cover off of this thing, whoop, that's putting the cover on. We want the cover off. Of course, since we're taping a TV show, the unit is just in a shutdown mode right now, but we can still show you the hardware. Maybe it'll kick on while we're talking. So what we have here is we have the control leads that turn the unit on and off. These are 220 volt lines, so they're in an insulated cable, and they go to the controls. We have the power coming in here, which goes in behind the power panel. There's all the controls for the unit behind here. We have the compressor. This is what makes a refrigerator work, whether it's a heat pump or it's a refrigerator or it's a freezer. Compressor takes the refrigerant, which used to be a product like Freon. They don't use Freon anymore. They use environmentally friendly refrigerants now, and it compresses it as it goes through the refrigeration cycle. And there's two heat exchangers here. There's the one up here, which is this fan coil. The refrigerant is in these tubes that you see here. The other heat exchanger, I try to get out of the light, we all try to get out of the light here, is back here. It's this gray circular thing. And that has refrigerant on the inner part and water on the outer part. And what that does is exchanges the heat that's being generated by the compressor doing its thing and pumps it into the tank. And of course, the last piece of the puzzle would be this reddish circulator pump back here. That's a bronze circulator pump right there. There you go. We get the light going. That's a bronze circulator pump. We don't use iron or steel pumps in potable water systems because they will rust. Potable water being water that would come out of your tap. There's a lot of oxygen in it, so you have to use something that's non-corrosive. In this case, a bronze circulator pump is a standard industry item. All this is put together, obviously, in a package assembled here in assembled in Bangor, Maine. And then there's electronic control that tells things when to turn on and off and to make all the cycles run properly, because there are cyclical type things that have to take place to make all this function. But that's the whole unit as a package, and it's fairly compact. And it was, as a conventional installation, if you don't have a weird tank like I have here, it's a pretty straightforward thing. And they've used these a lot in other parts of the country. Nile has sold these in New England, and where you're using electric hot water, we get this advantage over straight electricity. What kind of advantage do you get? Well, we talk about, with heat pump cycles, a coefficient of performance. So if a standard electric water heater, which is 100% efficient, because all the electricity goes in the hot water as you heat the tank, a heat pump has what we call coefficient of performance, which is above 100% efficiency, because we're taking energy out of the air. It's not a perpetual motion type thing. We're taking energy out of the air, compressing it to make it hotter, and we're making the electricity do more work for us. So we get COPs on this unit of, I think, between the 2 and 3 range. So that means for every unit of electricity we put into it, we get 2 to 3 times that out in heat energy by extracting heat from the surrounding area. So that's an advantage. So it's 2 to 3 times more energy than a regular electric water heater. That's the heat pump water heater. That's the refrigerant. Yeah, that's the compressor of the heat pump water heater coming on. I was waiting for that to happen. It's fairly audible right here with the cover on it. It's nowhere near as audible, and of course upstairs you don't hear it. This is like an air pump. It's a compressor. It's compressing the refrigerant within the closed loop. You don't have to know anything about this. The people at Nile pay attention to that. You just need to have water coming in and out of it and electricity going into it, and the rest happens. Of course, no flue pipes, no fuels other than the electricity coming into the house. And just for kicks, we're going to put the cover back on, and you'll see what the difference is, okay? All of a sudden, pretty cool, huh? So it's a pretty well engineered device. I'm going to put this off right now because it's quiet, it's efficient, it's an alternative to other fuels. Everybody has electricity in their house, so this system works very well. The COP, just again to relate this to something, we're getting 6,000 to 7,000 BTUs an hour into this tank. We're inputting in. We can now, everything is running now, so we can go back to my my ammeter here, and this tells us how much current is going in. It's pulling about let's call it 3 amps of energy. 3 amps of electrical energy is going in. So it's 240 volts times 3 amps, that's 720 watts of energy going in, which is about 2,000 BTUs of electrical energy going into the unit. We've got 6,000 BTUs of heat energy coming out of the unit. It's kind of like a free lunch. There is no free lunch, but that's kind of like what it is. So in many applications, many situations, this is maybe a good fit. What we're going to do is we're going to pause here take a break, and when we come back for the last segment, we're going to fast forward about a month ahead in time, and we're going to collect some data, and we'll report back the data to you and what the actual impact is on an electric bill here, and then we can talk about that some more and wrap up the show. Anyway, we'll be back in a bit through the magic of time-lapse television, and we'll look at this in more detail, having some history under our belt. Stay with us, we'll be right back. Hey, we're back, and through the magic of television, it's 2 months later, and one thing I wanted to point out is if you store banjo necks in your basement and you have a heat pump water heater running, nothing's going to warp. So that's a good thing. That's why that's in that place of prominence. So, the drum roll, the answer to the $64,000 question is, we've run between $20 and $30 a month running this to give us domestic hot water and dehumidify the basement. And I think those are pretty good numbers, because we multiply that times 12. Let's see, that'd be carry the one is $240 to $360 a year. Not bad considering the alternative. And of course, other people are seeing similar kinds of savings. I think bigger households, you'll see bigger savings because you use more hot water. So this has proven itself, in my book, to be competitive against other forms of domestic hot water heating. Of course, especially if you have a electric water heater in the basement, which, again, we don't. I have another place I think we want to try a water heater like this, and that's in a wet basement, to see what it'll do to keep the wet basement from being overtly wet. In other words, trying to keep a lot of the free moisture that's exposed on an old dirt floor, maybe another project. So we'll see about that as in upcoming shows. But so let's just recap a little bit here. This is great for backup for a regular electric water heater, because it's going to cut your water bill, your hot water electric bill, a lot. If you have a solar system, I think it makes perfect sense. This is a perfect backup for a solar system. Again, for all the same reasons, it's going to save money, and most solar systems use electric backup, electric resistance heaters in a traditional electric water, or something similar to a conventional electric water tank. It's got electric elements in it. It's got electric elements in it. This interfaces very easily with it, so that makes a lot of sense. You got a wood stove in the basement. It's going to be like money from home, because it's going to be a very simple process to scavenge waste heat off the wood stove into domestic hot water without having to have any coils, with no explosion risks, all the things that we worry about when we have a wood stove. We want to put a coil on it. The other one is if we have a wood furnace in the basement. Makes tremendous sense, again, for all the same reasons. The wood furnace, we've got a lot of excess heat in the basement that we don't necessarily need to have down there, so if we can harvest it and store it for domestic hot water, we're ahead of the game. And it's a very simple system, because there's, again, no direct coupling between the two. Same thing holds true for a coal system. If you have a oil-fired furnace, you're making hot air with a furnace that's fired by oil. Many times you have an electric water heater for backup. Again, perfect sense. So we have all these great options. There's places where you might not want to, supplant a conventional oil system, but maybe you would if you have a dehumidification problem. If it's moist in the basement and you need to have it dry because you're storing banjo necks or banjo parts or doing anything where it needs to be drier in the basement, this makes tremendous sense. And of course, this has mitigated any other mold or mildew issues we've had in the basement since we started using it, and that was just a wonderful side benefit to having this thing working. Now the other opportunity is if I wanted to air condition in the summertime, I can again, take this off. I should have a filter over this where that's cold, and we could feed air in here, return cooled air out here to wherever the office was or the place that we wanted to air condition. If we wanted to feed this from a sun space on the first floor or even put it in the sun space, we could do that. So we got a lot of possibilities, and it's a great tool. It's $600. That's not a lot of money for almost anything you touch for heating. I guarantee is going to cost you more than $600. So we have a great opportunity here, and again, it's made right in Bangor Brewer area. So that's wonderful. It's not made somewhere else and brought in and sold in the area. It is made right in our backyard. So we've got that going for it, and it's a really interesting technology. I've got about a gallon of water sitting here right now. I seem to be generating, now we're in the off season, now we're in autumn, I generate about 5 gallons of water over the course of about 2 to 3 weeks, depending on how rainy it is and how damp it might be in the basement. So that's worked very well for us. We have more distilled water than we need right now. So what I might do is run a permanent drain over to the floor drain so we can get rid of any excess distilled water, and then when I need distilled water, we just put a jug in there. This isn't a simple do-it-yourself project because the 220 and tying in with an electric water heater, but it's something that if you know a little bit, if you can put in your own water heater, you could put in one of these things. And if you can't do that, you don't have that kind of skill, hire a plumber and an electrician and get the thing hooked up properly, because it's definitely worth a look-see. If you have questions, give us a call on the radio. You'll see we're at the end of the show. This is the kind of technology that I think we need to have, considering what fuel costs are doing. The beauty of it right now is electrical costs have not gone up in sync with oil prices. Oil prices have come back down again, but this is still competitive. So it's not a volatile fuel the way costs, related to costs the way fossil fuels are. So we've got that wonderful thing going for us and all these side benefits. If you're running a dehumidifier in the basement, we definitely need to take a look at this. Anyway, we got to go because we are out of time. We'll have probably an update on this in about 6 months just to give you an idea what's going on with it, and we may even try another installation somewhere else. Also, Nile Corporation makes a cold climate heat pump which makes heat and air conditioning out of the same unit cost effectively from outside air. So there's no groundwater pumps, no well pumps or anything like that, and it's made for our climate. Give them a look again, niletherm.com. You'll see we're at the end of the show, and we will see you next week where we will have another fun project to take a look at.